Hello friends, today our title is electric current. I will solve practice of 7C. The first one, if the current in a wire of a CD player is 5 milliampere, the current is given I is equal to 5.0 milliampere, and when we change it to ampere it will be 10 to the power of minus 3 ampere. And then it says how long will it take, that's what you wanted. That 2 coulomb charge to pass through that cross-section area. Q is given as, Q is 2 coulomb, 2.00 coulomb. So, what we learn, I is equal to delta Q over delta T, current, current is the time rate of charge that flows past through a cross-section area. Here delta T wanted, so if we cross multiply, delta T will be delta Q over I. So delta T is equal to, what is the charge? 2 coulomb, 2.00 coulomb divided by I. I is equal to 5, 10 to the power of minus 3, 5 multiplied 10 to the minus 3 ampere. Then the delta T here will be delta T 2000 divided by 5 is 400 ampere, or we can write it for 10 to the 2 ampere. As I say, delta T for 10 to the 2 power of 2 ampere, also possible. Oh, sorry, mistake. That's second. Okay, second question. In a particular TV tube, the beam current is 60 microcoulomb. I is given. It is equal to 60 microampere. I is 60 microampere. And it's equal to 60, 10 to the power of minus 6 ampere. Then the number of electron is given, and number of electron that pass is given instead of charge here. 3.75, 10 to the power of 14 electron pass. How long does it take? Delta T wanted. And it says here, giving an hit, it says charge of electron is equal to 1.6. It says minus, but here we are calculating amount of charge. So it is 1.6, 10 to the minus 19 coulomb. As I say, I calculate magnitude. Delta T wanted. What we learned, delta T is equal to delta Q divided by I. But I don't know Q. Since charge is given, I will calculate here delta Q first. Delta Q is equal to N multiplied charge of an electron. Total charge here is equal to N. The number is given 3.75, 10 to the power of 14. Multiply Q, charge of an electron is 1.6, 10 to the minus 19. When we multiply them, we will get charge as Q is equal to 6 multiplied 10 to the minus 5 coulomb. So then let's calculate delta T, charge divided by charge. We get 6 10 to the power of minus 5 coulomb divided by the current. It is 60 10 to the power 6 ampere. If you check and the 6 10 to minus 5, 60 10 to minus 6 are same when we divide it, so delta T here will be 1 second. 3. An emitter wire carries a current of 80 milliampere. I is 80 milliampere, and it is equal to 80 multiplied 10 to the power of minus 3 ampere. How long does it take delta T wanted? For 3 10 to 20 electron to pass. Again, n given. 3 10 to the power of 20 electrons to pass from the cross section of that conducting wire. Again, I need that delta T is equal to delta Q over I. Here Q we have to calculate the other side. Delta Q is equal to, or direct I can write here, delta T is equal to, instead of delta Q I will write N multiply QE. This is delta Q multiply, divided by I. So delta T is equal to, what is N? 3 10 to 20 multiply, what is charge of electron? 1.6 10 to the 19 minus 19 coulomb divided by I. I is 80 10 to the power of minus 3. When you calculate them, you will get delta T as delta T is equal to 600 seconds. Delta T is equal to 600 seconds. 4. The compressor on an air conditioner draws 40 ampere current. I is 40 ampere, 0 ampere. And when it's start up, if the start up time is 0.5 delta T given 0.5 seconds, how much charge pass at the Q? I is equal to delta Q over delta T. Delta Q wanted, if we cross multiply, then we will get the delta Q is equal to I multiply delta T. Then delta Q is equal to I is given 40 0.0 ampere multiply delta T 0.5 seconds, and then the charge will be 20 coulomb. A total charge of 9 millicoulomb passed through the cross-section area. I will say Q1 here, delta Q1. Delta Q1 is 9 millicoulomb. We will change it to coulomb across through the cross-section. Delta T is given 3.5. Delta T is 3.5 seconds. I need too much place, so I start from the top here. First one, it says what is the current? A, the current one. This is easy. B, it says how many electron pass? N wanted here. N wanted, but for 10 seconds. It says if delta T 10 seconds. Delta T 10 seconds. And then C, it says what is the current? Now I wanted if Q increases 2 times, and instead of that charge, if you move more charge, 2 times more charge than this. A, let's start with A. I wanted, I is equal to delta Q here, Q1 over delta T, and I is equal to delta Q 9 10 to the minus 3 millis, it says, coulomb divided by T, 3.5. Then I will be 2.6 10 to the minus 3. 2.6 10 to the minus 3 ampere. We get I. B. Say what is N? N is equal to total charge delta Q divided by charge of an electron. How can I calculate total charge here? It is equal to I multiply delta T2. Now delta T2, this part, if it says 10 seconds, now it is not delta T1, 3.5 is first time and interval, and 10 seconds is second time interval, divided by charge of an electron, QE. Then it is equal to, what is I? I will calculate 2.6 10 to the power of minus 3 multiply duration. Duration is 10 seconds divided by QE, 1.6 10 to the minus 19 coulomb. Then N will be here. N is equal to, if you use calculator, you will get 1.6 10 to the 17 electron. C. It says what is the current if charge increased 2 times? I is equal to now delta Q prime, now new charge, it is not the previous one, over delta T in same time interval. So the delta Q prime is equal to 2 times delta Q divided by delta T. It is equal to 2 multiply, what was delta Q at the beginning? 9 10 to the minus 3 coulomb divided by time 3.5 seconds. Then I will be here. I is equal to 5.1 10 to the power of minus 3 ampere. It's around 2 times bigger than the previous one. Thank you.